Bismillahirrahmanirrahim. Topic 6, Lesson 5, Properties of Special Parallelograms. So our main objective is to use the properties of rhombuses, rectangles and squares to solve problems. And secondly, we will try to understand the relation between the diagonals of rectangle and parallelogram and rhombus. So here are the main, you can say, three shapes that we are going to discuss. The first one is the rectangle. So what is the speciality of the, or you can say what is the special property for the rectangle? It says if a parallelogram is a rectangle, then the diagonals are congruent. So we can say that if you look at this rectangle ABCD, in this and the other thing is these diagonals, when they intersect each other, so the diagonals get bisected. So we can say, let's say if this point is O, then DO will be congruent to OB. That means that this part will be equal to this one, and similarly AO will be equal to OC. So this part will become equal to this one. Clear? Okay. If we look at the shape of the rhombus, there's a special property for this rhombus. It says if a parallelogram is a rhombus, then the diagonals are perpendicular and bisect each pair of the opposite angles. So if you look at the two diagonals of the rhombus, they are not congruent. So that's why this rhombus is different from the rectangle, that in the rectangle the two diagonals are congruent. Here the diagonals are of different size, right? But what do? They are, first thing, they are perpendicular to each other. So you can see here it's written PR is perpendicular to QS. PR is the first diagonal, or you can say one of the diagonal, and QS is the other diagonal. They are perpendicular to each other means they make right angle with each other. So if you remember in the last video of lesson 6.4, I explained you that when we draw these diagonals, we get four congruent triangles in a rhombus. Okay, now in this, you can say in this rhombus, the opposite pair of the angles, they get bisected because of these diagonals. So we can say that this angle Q is equal to angle S as a whole. But when we draw the diagonal, what happens? The angle, it is cut into two parts. So we get two pairs of congruent angles. So you can, in other words, you can say all these four angles are congruent to each other. And similar is the case for this point P and R, or you can say angle P and R. Because of drawing this diagonal PR, we will get two pairs of angles, and all these angles are congruent to each other. Right? Now look at the square. What is the special property of the square? If a parallelogram is a square, the properties of both rectangle and the rhombus apply. That means that both the diagonals will be congruent. This property, it is like the rectangle, and the diagonals get bisected. This property, it comes from the rectangle as well. And by the way, if they get bisected means this part will become equal to this part, and this part will become equal to this part. All these four parts will be equal to each other. But in case of rhombus, yes, you can say this part is congruent to this one, and this part is congruent to this part, but not all the four parts will be equal, right? But in this case, all the four parts will be, all these four segments will be equal to each other. Now, and then both the diagonals, they become perpendicular to each other. So here you can see that the diagonals are perpendicular, and WY, the diagonals are also congruent. So you can say that a square, it takes properties of both the rectangle and the rhombus. Is that clear? Okay, let's see what do we have next. Now in theorem 6.16, it says if a parallelogram is a rhombus, then the diagonals are perpendicular bisectors of each other. Perpendicular bisectors of each other mean not only they will be perpendicular to each other, but also they will, this point will become the midpoint, and the two diagonals will be bisected. Clear? Like for example, let's say in general, if this one will be 2 centimeters, this one will also be 2 centimeters. If this one is, let's say, 4 centimeter, this one will be 4 centimeter. So that means the diagonals, they are not only perpendicular to each other, but also they bisect each other. Is that clear? Okay, next we have theorem 6.17. It says if a parallelogram is a rhombus, then each diagonal bisect a pair of the opposite angles. Already I explained you this property over here, that the opposite angles, all this pair and this pair will be, these two pairs will be equal to each other. So you can say all these four angles are congruent to each other. And if you look at this, where my cursor is moving right now, this pair, all the four angles will be congruent. So if you look at this diagram, this is the best example. Look at this. Here we have 31, 31, 31, 31. So that means this whole angle is bisected, this whole angle is bisected. Now if you look at the green ones, this is 59, 59, 59, 59, means the opposite angles, they get bisected. So you can say that we get a pair and this pair, the pair, the angles of these pairs are congruent, and then we have this pair and this pair. So angles of these pairs are also congruent. Now let's solve some questions. Now here the first example, it says quadrilateral GHJK is a rhombus. So we know that this shape is a rhombus. To solve this, the problem that they want us to find GH. So to find GH, I will think about all the properties of the rhombus. Now, where is GH? This one is GH, right? So to find GH, I need to find HJ. Why do I need to find HJ? Because all the four sides of the rhombus are congruent. So if I will be able to find how much is HJ, it will be the same as GH, right? Now, next step to think, how can I find HJ? It says HJ is 3x plus 1 until I do not have the value of x. How could I get the value of HJ, right? So let's first of all find the value of x. How can I find the value of x? Now look at the two diagonals. This diagonal J and G, this diagonal JG, it's being bisected here because both the diagonals, they get bisected when they cross each other. So you can say 2x plus 3 will be equal to 4x minus 7. So let's write. So it will be 2x plus 3 equals 4x minus 7, right? This is the midpoint of this diagonal. Now move this 2x over there, it will turn into negative, and bring this 7 over here, it will turn into positive. So we will have 3 plus 7 on this side and 4x minus 2x on the other side. So this will give us 2x equals 10, and when we divide each side by 2, so it will give us the value of x, that is 5. Now we will substitute this value of x over here. So it will give us 3 times 5 plus 1. So it's 15 plus 1, that is 16. So I can say that GH, the one that I'm trying to find, is actually equal to HJ. And what is the value of HJ? It's 16. That's why the value of GH will also be 16. So this will be the final answer. Hope it's clear for you. Here is the next question. I have taken it from the triad questions. Triad 2, it says each quadrilateral is a rhombus. So we have A part and B part. So they are saying each one of these is a rhombus. What is the value of angle MNO? Where is angle MNO? Let's check. MNO. So they want us to find that how much is this angle, this whole angle, right? So if this angle is 62, in the rhombus, all these four angles, or you can say this pair is equal to this pair. So this one will be 62, this one will be 62, and this one will be 62, right? Or I mean, it's simple now. The sum of all the four angles of a rhombus is 360, right? So what we can do now, we can to find angle MNO. First let's find let's find first of all what is 360 minus 62 plus 62 plus 62 plus 62, right? So let's see what we will get. Wait, so it is giving us 112. So the final this is the not the final answer, actually it's 112 degrees. Now this 112 degrees is for this pair and for this pair, because we are trying to look for the angle MNO, That means the measurement of angle MNO will be half of this, because this 112 is for both these angles. So if you take half of it, because both the angles are equal, so you can take the half of it, that will be 56. So the value of angle MNO will become 56 degrees. Clear? Okay, now look at the B part. It says find QT. Now where is QT? This part is QT, right? So until I do not have the value of y, I cannot find how long is QT. So how can we find the value of y? Because it's a rhombus, so that's why this part PS will be congruent to SR, right? So we can say PS is congruent to SR, because all the four sides of a rhombus are equal. So that's why we can say PS is equal to SR. Remember, we always need an equation to find the value of the variable. So PS is actually 3y minus 1 and SR is actually 2y plus 3. Now move this 2y on this side and 1 on the other side. So we will have 3y minus 2y equals 3 plus 1. Right? So this one will give us the value of y, that is 4. Now we are going to use this value of y to find the value of QS, because we are not given how much is QT, right? So let's find first QS. So how we will find QS? The whole from Q to S is actually 5y minus 4. So 5y minus 4, let's substitute the value of y into it. That is 4. So 5 times 4 will be 20 minus 4. So QS, all this line from here to here is 16. And QT is half of it. How do we know it's half of it? Because both the diagonals, they bisect each other. So this is the midpoint. So if I want to find QT, I need to make half of this 16. That will give us 8. Is that clear? So the value of QT will become 8. Here is the next theorem number 618. It says if a parallelogram is a rectangle, then its diagonals are congruent. So already I explained you in the beginning that whenever you have a parallelogram that is a rectangle, then the two diagonals are congruent to each other. And here is the example. You can see that from here A to C, the diagonal measures 13 units, and the other diagonal B to D, it also measures 13 units, because it's a rectangle. And how do I know it's a rectangle? Because all the four angles here are 90 degrees. This is the first thing. The second thing is the opposite sides are congruent. The left hand side is congruent to the right hand side, and the upper side is congruent to the lower side. Clear? So let's see what do we have next. Next here it says try it number 3. A carpenter needs to check the gate his apprentice built to be sure to it is a rectangular. The diagonal measures 52 inches and 53 inches. Is the gate rectangular? So it's not a rectangle. What is the reason? Because just like in this theorem I explained you that the two diagonals, they should, if it's a rectangle, the diagonals have to be of the same measure. But here in this case the diagonals are not of the same measure, so we can say the diagonals are not congruent, then it is not a rectangle. Actually this question says that the square ABCD has the diagonals AC and BD. So these are the two diagonals, right? AC and BD. Okay, they said what is the measure of angle ABD? So let's highlight angle ABD. So angle ABD is actually this one. So they want us to find that how much is the value for this angle. Now we know that in a square all the four angles, like here this angle is a right angle, this angle is a right angle, and this angle is a right angle, and this one is also a right angle. Secondly, we know that like a rhombus, when you draw the diagonals, each angle it gets bisected. So that means this angle is bisected. So all these four pairs of you can say four angles will be congruent to each other. So each angle will be how much? So because the angle 90 degrees, it gets bisected, so each angle will become half of it. That means each angle will be 45 degrees, right? So we can say that measurement of angle ABD is actually the half of the 90 degrees, so it's 45 degrees. Clear? Now let's solve some questions from the lesson. It says from question number 18 to 20, find each angle measure for the rhombus ABCD. So this ABCD is actually a rhombus, and here in question number 18 they want us to find the value of angle ACD. Where is angle ACD? Angle ACD is actually this angle, right? Okay, now because it's a rhombus, so I can say the value of this angle will be actually 7x minus 6. Okay, if this angle is 7x minus 6, how much will be this angle? Because again this is a diagonal, I mean BD is the diagonal, so this angle will be how much? It will be 4x minus 3. Okay, now how much is this angle? Because it's a rhombus, both the diagonals will be perpendicular to each other, so this angle will be a right angle. If you notice that I'm trying to complete all the three angles of this right angle triangle. As I told you when I started the lesson, that in a rhombus, when you draw the two diagonals, we get four congruent right triangles. So this is a right triangle, so it means if I add all these three angles, their sum will be 180. And why I'm doing this, why I'm making this equation? To find the value of x. So we can say that 7x minus 6, if I add it into 4x minus 3 and then I add it into 90, the sum of all these three angles will be 180. Now collect the like terms. 7x plus 4x will become 11x, negative 6 and negative 3, and it will be negative 9 plus 90, so it will give us plus 81 equals 180. I mean complete. So let's solve this equation. So here is the answer for this question. You can see that first I found the value of x. From here it was giving us 11x equals 99. I divided both sides by 11, so it gave me the value of x. Now I will use this value of x to find the value of angle ACD, which is actually 7x minus 6. So substitute the value of x here, that is 9. So 7 times 9 will be 63, minus 6, it will give us 57. Now in the next step, question number 19, they are saying for the same diagram, find the value of angle ABC. So where is angle ABC? It's here, this one. Let me show you. ABC. So actually they want us to find this angle ABC. So if we find this angle ADC, this one, it will be the same as angle ABD. So let's find how much is 4x minus 3. So 4x minus 3 means substitute the value of x, that is 9. So 4 times 9 will be 36, minus 3, it is giving us 33. So we can say that this angle is 33, this angle is 33. So the opposite pair will also be having the same values, 33 and 33. So to find the value of measurement angle ABC, what we will do, we will add 33 with 33. So it will give us the value of this angle, that is 66 degrees. I hope it's clear for you. Now they said find the value of angle BEA. Where is angle BEA? So let's erase this one, and BEA, let's make it with the pink color. Where is BEA? This one is B, this one is E actually, and BEA. So they want us to find how much is this angle. So we know that the two diagonals, they are perpendicular to each other, so that's why this angle will be 90 degrees. So the value of this angle will become 90 degrees. Clear? Next it says for exercise 21 to 23, find each length of for rhombus PQRS round to the nearest tenth. So they want us to find how long is this TR. Where is TR? How long is this TR? So to find TR, if I will be able to find how long is PT, because it's given it's 2x plus 6. So this one will also be 2x plus, not 6, sorry, 2. It's 2x plus 2. right? So do we have the value of x? No, we don't have, right? How can we find the value of x? Because this part, or you can say this segment, will be equal to this segment because of the two diagonals of the rhombus. The diagonals get bisected, so we can say that 4x minus 7 will be equal to 2x minus 1. So 4x minus 2x will be equal to negative 1 plus 7, because I moved this 7 here and I moved this 2x here. So we have 2x equals 6. Now divide each side by 2. So it will give us the value of x, that is 3. Now use this value of 3 to find TR. Now TR is actually equal to 2x plus 2. Now we can substitute the value of x, that is 3. So 3 times 2 will be 6. Add into it 2. So it will be 8, right? So the value of TR will be 8. Next, it says find the value of QS. So let's to find the value of QS, as you can see here, this is QS. Where is QS? This whole line is QS, right? So if you know what is the value of 4x minus 7, what is the value of 4x minus 7? Substitute the value of x here. So it's 4 times 3, 12, minus 7, it will be 5. So this one will also be 5. That means this one is 5 and this one is 5. So QS will become equal to 5 plus 5, that is 10. Clear? Now in question number 23, they want us to find that how long is PS. So where is PS? They want us to find like how long is this line. We know that this part of, if I look at this triangle, this part of the triangle P, let's name it, let's say this point is O. So PO is how much? It's 8, right? And how much is this part? This one is 5, and it's a right angle triangle because both the diagonals will be perpendicular to each other. So we can use the Pythagorean formula to find PS, the hypotenuse. So hypotenuse is equal to, this is the formula, that if we are trying to find the hypotenuse, it is always equal to the square root of the sum of the squares of the legs, right? Legs of the right angle. So now one of the leg of the right angle is 8, square it, plus the other leg of the right triangle is 5, so square it, so it's 5 squared. So let's check what is the final answer. So because we have to give the answer to the nearest 10, so the answer is becoming 9.4. Clear? Next question, it's about a square. It says find each length and the value for the square QR ST, round to the nearest tenth. Like you have to round each answer to the nearest tenth. So first of all, they want us to find how long is this SV, right? Okay, now look at this one. As you can see from here, the answer is becoming 5.66. 5.66 because I'm rounding it to the 2 decimal places. Why I'm rounding it to the 2 decimal places? Wait, I'll explain it to you. 5.66, right? So if I want to find SV, so SV will be actually the half of this whole line because both the diagonals, they get bisected. So we can say 5.66 divided by 2. So let's divide it by 2. So divide it by 2. So the final answer is becoming 2.8, right? So we have to give the answer to the nearest 10. So we will write it only to 2.8. Now they are saying how long is RT. So RT will be the same as QS, right? Because both the diagonals are congruent to each other, and we found the value of QS. It's becoming 5.66, rounded to the nearest 10, so we will write it 5.7. Clear? Next they said find the perimeter of the triangle RVS. Where is the triangle RVS? So this is R. Where is RVS? This triangle. Let me highlight it for you with a different color. This one. That what is the perimeter of this triangle? Okay, now we know that how much is SV. How much is this SV? We already found it. It's 2.8. So this line will also be 2.8, and we know that this RS is 4. So if you, to find the perimeter, we add all the sides, so it become 2.8 plus 2.8 and add into it 4, right? So what will be the sum? Let's check. So it's becoming 9.6. right, 9.6. So the perimeter of this green triangle will be 9.6. Here is the next question. It says what is the value of GC. So they want us to find this value of GC. ABCD is a square. So if it's a square, that means both the diagonals, the one that I'm drawing with the green color, let me draw it here, this one, this one, and the one that I'm gonna draw with the pink color, this one, these will be equal to each other. So this shows that F to C, this whole line will be actually you can say 16, right? This one will be, this whole line will be 16 because this part is 16, right? And this part is 10, so that's why this part will also be 10. So you can say here it will be 6 and here it will be 6. So the value of GC will be 6 units. Challenge questions. I want you to pause the video here and solve these challenge questions on your own, and then play the video to check your answers. Here are the answers for both the challenge questions. The first one, it was saying which word best describes a parallelogram with diagonals that are congruent and perpendicular. So only in case of a square, the diagonals are perpendicular and they are congruent. In the second question, they was asking you to find the measure of this angle ZYW. So they wanted you to find this angle. So this whole angle is 77 degrees. So this whole angle will also be 77 degrees. And this part will be the half of it, because it's a rhombus, so the diagonals will bisect the opposite angle. So this angle will become the half of 77. That means you need to divide 77 by 2. So it is giving us 38.5.